Hey, what's up, everybody? And welcome back to the sanctuary. Got a new boat. Must mean we got a new unit. I'm Professor C, and we're going to talk about A&P today, of course. And specifically, I'm going to get us into the histology section, and we're going to start off with a little bit of epithelial tissue. So, let's do it. But before we dive into histology, and that is again the whole unit, will be a deep dive into histology, the study of tissue. Remember, there are four major types: epithelial, connective, muscle, and nervous. And for this talk and a little mini talk that will come after this, we're going to cover the epithelial tissues in detail. One of the tricks that I always teach my students is to learn the ABCs of epithelial tissue. And the problem is when students start first looking at tissue slides, and there are so many of them to learn, they all kind of look the same. They kind of look like pink bubbles, and they look at the next slide and it's more pink bubbles, and then the next slide is more pink bubbles. And so we really have to learn some tricks to identify the differences between this versus that type of tissue. So if we can use this ABCs trick, we can identify epithelium almost every time immediately. So what do I mean by the ABCs? Well, A for apical. Apical is a free surface, and if you look at the top of this slide, up here, where this brick wall I've given you as a reference, pretend that brick wall is the epithelial tissue. Up at the top, where I'm writing an A here, that's the apical surface. That's the free surface. That is not the tissue. That is empty space, a cavity in the tissue, a lumen, perhaps, which is just kind of like the inside of a soda straw, where the soda would come up, would be the lumen. So we're looking for A, some sort of free apical surface. And then counter to that, B would be, we're looking for something at the bottom. So if I change my pen back to white, I can clearly see down here is the bottom of my brick wall. That would be what I would call the basement membrane, or the basal surface, which is attached to something underneath that's going to be our letter C. So if A is for apical and B is for this basement membrane, C will stand for connective tissue that underlies the epithelium. So one quick thing you can do is, if you think you're looking at an epithelial tissue, look for the apical surface, look for a basal structure at the bottom, and look for some connective tissue supporting that basement underneath. A couple of other characteristics of epithelium: tightly packed cells. As you can see, these bricks that would indicate the cells in the tissue are tightly packed. There is no space in between them. Avascular, meaning not, right? The A in front of a word tells us not vascular. There are no blood vessels in the epithelium. It lies underneath this epithelial portion. So true epithelium is avascular, no blood vessels. Innervated means it has nerves. And we won't see this too much in this chapter, but when we get into the skin chapter in the future, we will see nervous tissue, nerve fibers running through the epithelium. Highly mitotic. We saw in the last chapter, we talked about mitosis quite a bit. So what we mean is epithelial tissue divides quite often. It undergoes mitosis regularly. It's highly mitotic. Your skin is always falling off all over the floor, all over your house in the form of dust, and it replaces itself. I know this because we don't have big, blotchy, missing places of skin when we look down at our arm. To identify epithelial tissue, it's quite simple actually, but you have to look at the details. You need to look at the layers of the tissue, like we saw the layers of the bricks, and then the shape of the bricks themselves. So let's try to draw some of the basic shapes and layers that we find in epithelium. One layer, simple, pretty easy to deal with. If you see only one layer of cells, that would be a simple epithelium. If there are more than one layer, it's called stratified. Squamous is the word for squashed. I know some people call it squamous, but the word isn't squashed. And I remember squashed, squamous. But remember, it doesn't matter exactly how you pronounce these words. If you can get them correct on the test, it really doesn't matter. So if I were to draw a squamous cell, I would draw a cell that looks like, kind of like a fried egg. It's squashed down, flat. And let's say I wanted to draw simple squamous. Well, if I wanted to draw a simple squamous, I would need one simple, right? One layer of squashed cells. There would be simple squamous. What if I wanted to turn it into stratified squamous? Well, I would simply add more flat squash cells on top of it, very similarly to the way we had the bricks that made up the wall on the first page. All right, a cuboid cell, sometimes called cuboidal, but cube is the key here. It's like a box. So these cells are more boxy. And what I'm drawing here would be a simple cuboidal epithelium, a single layer of boxy cells. If I wanted to make it stratified, I could simply draw some boxes on top of the boxes, right? And I could get stratified cuboid or stratified cuboidal. The final common shape you see in epithelium is called columnar. They kind of look like refrigerators, like a column. That's why it's called columnar. So we see these tall cells, kind of like big tall refrigerators. I'm putting the nuclei in here so we know they're individual cells. And what I'm drawing here is a single row of long rectangular cells, columns, so that would be a simple columnar epithelium. If I wanted to turn it into a stratified columnar epithelium, I could simply draw some refrigerators on top of the row of refrigerators that I've already drawn. And now we have a stratified columnar epithelium. So at the heart of it, count the layers and look at the shape of the cells, and that can help you identify the epithelial tissue. And remember, we know how to identify epithelium by simply using our ABC rule: apical, basement, connective underneath. Okay, for each of these slides, we're going to get extremely specific, and we're going to do things like ID the cell types. Most tests, that's what they have you do, is identify, and of course that means giving a name to the specific type of tissue. There are lots of types of epithelium. Function, location of each type. This is critical, and this is what all the standardized tests will ask you: some form of identification, the name, the function, and the location. So we're just going to drill through these and look at lots of different pictures so our brain can get a taste of these tissues. So here's that fried egg look. If you can see, here's one simple squamous epithelial cell. Now you might be thinking, that doesn't look like the brick wall. And I know this is kind of a top-down shot. If I could take the bricks apart and lay the bricks out in the yard, this is what they would look like. And if you've ever had a class where you did some sort of cheek swab and you swabbed your cells and you colored them blue, this is exactly what they look like. Your cheek is lined with simple squamous epithelium, and they have this fried egg appearance. So if you see this fried egg look, go with simple squamous epithelium. Single layer of flat cells. Again, in this picture we can't see that. I could draw flat cell, flat cell, flat cell, flat cell, right? And that would be a simple squamous epithelium. Sometimes forms large rings. So what I'm going to do here is just take that simple layer and start curling it around. It's still a single layer of flat cells, but it's kind of making this ring dance where they're kind of holding each other's hands and dancing in a circle. And this middle part that's in the center, like the soda straw example, is called a lumen. Okay, now you're saying, wait a minute, where's the ABCs? Well, the lumen is the apical surface. The lumen is the opening. It is the free space. The basement, if I could change to a different color, would be here underneath the ring. So there's the B, the basement, and then the actual C, the connective tissue, would be out here completing the ring. So we do have an ABC system, just not in this image on this slide. I had to draw, but we will see this ring dancing idea in a moment. Function. Well, it's a simple layer. It's just one layer thick. So this would be a great layer for diffusion. Remember, if we want water or other substances to move across some sort of layer, like in and out, like this, we don't want a huge, big, thick wall like we saw on the first slide. We want a very narrow wall, just like this, something simple, so we can diffuse through it. Filtration and some protection. I mean, it does line your cheek, for example, but it's not going to protect too much, so I would say it's a minor protection. I would not throw down protection as a function unless you really couldn't think of anything else. Location, the lung sacs, the air sacs of the lungs called alveoli. Capillaries, which are the tiniest little blood vessels. It turns out the tiniest little blood vessels are made of solely simple squamous epithelium and some connective tissue under its basement. Kidney tubules, kidney filters called glomeruli, and the smooth inner lining of the heart called the endocardium. All right, my tricks again. Fried egg look like you see on this picture, the ring dancers like I've drawn on his pictures, and possibly you have a large lumen. If you see a large lumen, this open space in the center like a soda straw opening, you know you're looking at epithelial tissue. All right, here's another great picture, kind of top down. We see the fried egg look. Nice tightly packed cells, one layer deep, simple squamous epithelium, diffusion, filtration, a little bit of protection. All right, this is an example of a lumen. I'll put an L here in the center so you can see that is the very large lumen. And then let's look at the detail here. So that's the A, there's the apical surface. There's a cell right here. Here's a cell right here. Here's a cell right here. Here's a cell right here. And you can see there are large purple nuclei kind of jutting out into that lumen. That is the single layer of flat cells. And then below that would be the basement membrane here. And then under that would be the connective tissue that is supporting it. So we have our ABCs fulfilled. We have an apical surface. In this case, it's a lumen because we've got the ring dancers. We've got a basement underneath, and we've got a connective tissue that's supporting the epithelium. Same thing here. I see a cell here. I see a cell here. I see a cell here. And all those where these arrows are pointing are kind of pointing out, hey. And again, some pictures are better than others, and that's one of the things you have to deal with when you're learning histology. Some of the pictures are just simply not that great. This is not a perfect one, but we do see a very large lumen. We don't see a lot of connective tissue under the basement here, but again, not the best picture in the world. This is another example of the ring dancers forming a large, dozens of cells forming a large ring structure with the lumen in the middle. Again, this would be a great kind of diffusionary boundary. This is what the air sacs of the lung would look like. And we would see material, oxygen, carbon dioxide, being passed back and forth this membrane because it's easy to diffuse across a very, very simple layer. Another example, here's a cell, here's a cell, here's a cell. Sure, we'll just kind of fake that one. Here's a cell, here's a cell, here's a cell. Again, we got this ring dancer idea. What's in here? Well, here's the lumen. Looks like something's in the lumen. What is it? Who knows? It doesn't matter to us, but there's something in that lumen. And we got this example of these ring dancing simple epithelial cells. Okay, simple cuboidal epithelium. Again, simple meaning one layer. Cuboidal, going to be boxy shaped cells. And again, if I could draw it, you'd draw a box and a box and a box and a box, and you have your simple cuboidal. But these often form rings. So we're going to find the single layer of boxy cells, but almost in every picture you see on standardized exams, they form these tubular rings. So look over here where I'm drawing. There's a boxy cell. Here's a boxy cell. Here's a boxy cell. Here's a boxy cell. No, they're not perfect cubes. They never will be. There's a boxy cell. There's a lumen. And then right here would be the basement. And then connective tissue supporting the epithelial tissue. So we got our ABC, apical surface, basement, connective tissue. We have a single layer of cuboid cells. even though they're in a ring, you can see them there. Secretion and absorption, that's the function. Location, glands, glandular tubules. Kidneys, kidney tubules, again, tubes. And if these look like soda straws to you, they do to me also. So if I could get rid of this ink and kind of say, here's a soda straw, and here's a soda straw, it's like you've grabbed a handful of straws, and you're looking down through all the lumens. And you can see the ring structure there. It's very classic, simple cuboidal epithelium. Again, more numerous here, but I see soda straws. There's a soda straw, there's a straw, there's a straw. And if you look in detail, a boxy cell, a boxy cell, a boxy cell with lumens in the center. The dark basement around it with some little narrow layer of connective tissue. But that's what I'm looking at here is simple cuboidal epithelium. Function, secretion, absorption. Where would we find this? Kidney tubules and glandular tubules. Another picture. This is a pretty nice one. I like this. But same idea. Large ring of boxy cells. Large lumen in the center would be our apical surface. Basement underneath and some connective tissue. More simple cuboidal. One giant soda straw here. Large lumen in the center. Again, function is secretion, absorption, location, kidney tubules, glandular tubules. Another picture, you can see here the soda straws kind of look like you're squashing them now. They're a little bit more oval shaped, but it's still a single layer of boxy cells with large lumens. Soda straws are elongated now, but we still see them. All right, simple columnar epithelium. Same idea. One layer of extremely long and tall, rectangular shape, refrigerator-like cells. Simple columnar epithelium. The white stuff here, if I can change my color real quick, this here is the lumen, and it happens to be just folded over on itself. This is one long layer kind of folded back and forth. You can see it snaking around like this. Simple columnar epithelium. Single layer of tall cells is easy to identify. You may see some mucus cells that we'll get into a couple of times called goblet cells in here that are going to secrete the mucus. It's hard to see them in this image, but I'll show you some coming up. Function, secretion, absorption. And if the cells have cilia on top of them, we talked about cellular extensions called cilia, they will help move material around them. And this is very commonly found in the digestive tract and some glandular ducts. What do I see? Few goblets. In fact, again, I can't see the goblets here because they are so sparse. And this nice regular pattern of nuclei, this is what I mean by that. If I could take an arrow and shoot it through here, I can hit the nuclei like in one shot. They're not all scattered around. I don't have to go up and down and up and down. I can just shoot through here and pow, I can hit all these nuclei. That's what I mean by regular nuclei. It looks like kind of like a train of nuclei with each of the cars right behind the other. More simple columnar epithelium. I'm not sure what the arrow is pointing to. Let's ignore it completely. But again, long, rectangular, boxy columnar cells. We have a bright white lumen up above there. We have a nice basement below. Notice this is folded over as well. And we have some other kind of connective tissue as support underneath. Simple columnar, again, function, secretion, absorption. Location to be the GI tract, the digestive tract. Another great picture of simple columnar. Again, if I shot an arrow through here, I'm going to hit all the nuclei in one shot, screaming to me that this is simple columnar. Up to the left, we see the white open space of the lumen. I see a basement here very clearly, and then under the basement, all this wiggly stuff down here is connective tissue supporting that columnar epithelium. Another good picture, and I really like this because I can see here some of this mucus forming. These kind of white bubbles you see here is mucus, and it's probably going to be ejected out of here. So we would call these goblet cells. So straight shot arrow, I can hit most of the nuclei with one shot. I've got an apical surface above. I've got a basement below. I've got connective tissue supporting the epithelial tissue. All right, another good example of simple columnar. And I can kind of put a bracket here around it. It's folded over on itself, like so. And let me change it to a white pen so it stands out a little better. There it's folded over. Here's the connective tissue underneath the basement. And again, straight shot the nuclei with an arrow. Simple columnar epithelium. Secretion, absorption, located heavily in the GI tract. Now this one's a little different. First of all, notice the cilia here on top sticking out into the apical surface. Try to shoot an arrow here now. If you shoot an arrow here, you hit some of the nuclei, but you missed a lot. It looks like there's nuclei on top of nuclei. I still have an apical surface where the text is. I've got a basement down here, and I've got connective tissue underneath it where I'm drawing my scribble. But these cells look weird. It looks like not a train, but a train wreck of nuclei. Again, I can shoot an arrow here, and I can hit some of the nuclei, but I can't hit them all. So ID-wise, I would call this a garbled mess of tall cells. A mess, like a train wreck. Tall cells that look like they're on top of each other, but they're not. Many goblets, often ciliated. Function, mucus secretion, absorption, and removal of particles. Location, respiratory tract. Respiratory airways, both nasal and further down into the lungs. And the trick again that I use is if you shot an arrow through it, you get a train wreck of nuclei. Again, I can shoot an arrow like this, and I can hit most of the nuclei, but all these down here I'm missing. So it looks like it's stratified, but it's not. It's falsely stratified, pseudostratified columnar epithelium. And I would add the word ciliated to this mess as well. Ciliated, pseudostratified columnar epithelium. Lots of goblet to secrete mucus. Function, secretion, in this case, could be absorption. Location is respiratory tract. These cilia moving back and forth, especially as you sleep at night, to move particles up out of your respiratory system that you've breathed in during the day. Another good shot. I can shoot through here and get a lot of nuclei, but I can't get them all. Lots of goblet cells, ciliated cells, pseudostratified columnar epithelium. Nice picture showing it here. Here's my basement. Here's my connective tissue underneath. And again, it looks like we have multiple cells on top of cells, but they all actually do touch the basement, even though they're crammed in like sardines. So I would call this ciliated, pseudostratified columnar epithelium. Function, secretion mainly from all those goblet cells secreting mucus, and possibly absorption in other places. But this would be found in the respiratory tract very commonly. All right, here's the next picture, stratified squamous. Now this is a little tricky. So what I'll do is I'll first draw the basement right there. And then underneath the basement will be connective tissue, all this down here, fine. But what I see at the very bottom are kind of boxy shaped cells. And this can be misleading to a lot of people. But here's the rule. If you have a stratified tissue, and we obviously have more than one layer here, there are 20, 30, 40 layers? We're not going to count, but there's a lot. Notice how they're boxy at the bottom. But as you go closer and closer to the top, how they get more squashed and squashed and squashed. So if you're going to name a stratified epithelium, you name it based on the cell type at the apical surface. So because the apical surface here is at the top of the image, these cells up here are indeed squashed flat. And so I would call this stratified squamous, not stratified cuboidal. Even though the basement is, loaded with cuboidal shaped cells, the top is what we name it on by the apical surface. So this is stratified squamous epithelium. Many layers Way more than 2. I mean, you can count them here, but I just put 20 plus because there's a lot of layers here. Basal cells are boxy, but the apical cells are squamous. Protection, protection, protection. That's the default answer on stratified squamous. There are lots of layers because it's to take hits, it's to take abrasions to be rubbed off, sloughed off, and then regrown from the basal surface. Epidermis of the skin, the esophagus, the mouth, pretty much any opening of the body that you can think of is probably lined with stratified squamous epithelium to protect those openings. I don't know any tricks to this except once you see it, you kind of don't forget this one. When we do our skin chapter in the future, you'll notice that this is the top of the skin, the epidermal layer of the skin. And once you see it a few times, it'll be something you never forget. Nice picture. Here would be the basement at the bottom. Underneath the basement is connective tissue. Down here, we got an apical surface at the top left of the slide. And again, I see some boxier cells at the bottom, but many, 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 many layers of cells as we move up toward the apical surface. And then the cells are becoming flatter and flatter and flatter as we move up toward the top. And eventually they're going to be completely dead, squashed flat at the top, and will fall off all over your house in the form of dust. Protection, protection, protection. Location, skin, and other body openings. Not as good of a picture, but we can come down here somewhere and say the basement's somewhere there, connective tissue's somewhere under here, not the best. We still have a nice apical surface. And we have many, many, many layers of squashed flat cells. And the further we get up here, the more squashed they become. All right, stratified cuboidal. This is rather rare, and I want to show you a couple of images of this, but they often form rings. And here we do have multiple layers of boxy cells, but it's hard to find really good images of this anywhere. So they're often left out of textbooks completely. They might show 1 or 2. But let me illustrate it that way. There's our double layer, right, of cuboid cells. We do have a lumen in the center. We do have a basement here and connective tissue further below it. So we still have our ABC of epithelium, but now we have multiple layers of cuboid cells that do not become flat as they reach the apical surface. 2 or more layers of boxy cells. 2 is usually it. They often line ducts, and that's going to be the location, is lining ducts and their function. But they are quite rare. So sweat glands, mammary glands are usually the default answers on exams, but this is usually left off of exams because this tissue is rare. All right, transitional epithelium. Same thing, we can play the ABC game. If we look up here, we see an apical surface. There's a lumen. And in this case, what would be in this lumen is urine. So the place that I find this specific type of tissue, transitional epithelium, is found in the urinary bladder. And right here is your basement. Let me change that color so it jumps out at you a little bit better. There you go. And then here's some connective tissue underneath it. Now, what you see here is kind of teardrop-shaped cells, kind of like this here and this here. And there are some tricks to this, but I want to kind of show you this here. It kind of looks like some eyes and a mouth, kind of like over here, this famous painting called The Scream, where you see the guy's face. I see this in transitional epithelium almost every time I look at a good image. I see this Scream guy. So let's go through some of these tips and tricks here. A mess of teardrop-shaped cells. Function is distension, that is, it's called transitional. As urine fills up the urinary bladder, this tissue will act kind of like springs on a mattress, and it will squish down. The main place you hear about this being located is the urinary bladder, but you may find this in some of the kidney tubules and the ureters, which are the tubes that lead from the kidneys down to the urinary bladder. Tips and tricks for me. Some of this looks like a peacock's tail sometimes. You may see, especially at the top of the tissue, and by the top I mean near the apical surface, binucleate cells that have two nuclei. This is very common. It's not an absolute trick, but it does work on many of the really good slides. You can see these double nuclei. Or the screen picture down here. I see this guy's face in the pictures. Let's look at another one. Look at this right here. There it is again. You can even see his nose now. He's got his two nostrils there. It's kind of creepy when you see it. Up at the top, binucleate cell. I see a cell at the top with two nuclei. Nice basement and connective tissue underneath. Again, where would we find this? The urinary bladder. What's the function? Well, to transition, to distend, to squeeze down whenever the apical surface is filling with urine. More transitional epithelium. Let's find the scream guy. Where's a good one? There we go. Beautiful. Again, this is more the peacock's tail kind of idea. These dome-shaped, these teardrop-shaped cells. And there we go again. There's a binucleate cell near the apical surface. Nice distinction of a basement and the connective tissue underneath. Really good picture of transitional epithelium. All right. If you liked the epithelial slides, come back and watch some more. See you in the next one. Bye-bye.